Hello class, welcome to this video on the Cycle 2 practice. So let's go ahead and start with number 1. It says a board is 94 centimeters in length and must be cut so that one piece is 22 centimeters longer than the other piece. Find the length of each piece. Okay, so here this length has to be 94 centimeters. And so we have something that kind of resembles SAP, right? Where you have two line segments that make up the whole. And so by the segment addition postulate, we can say that, okay, we have x plus 22 has to equal to 94 centimeters. And there you go. And so now we can solve the equation by combining the like terms, subtracting 22 on both sides. Now we can divide by 2 on both sides. We get x is equal to 36 centimeters. Now x is the smaller piece, right? So this is the 36 centimeters. And the other piece is x plus 22, which is 36 plus 22, which is 58 centimeters. So then this one has to be 58 centimeters. All right, so we have the smaller piece is 36 centimeters and the larger piece is 58. All right, so number 2 is suppose M is the midpoint of FG. If Fm is equal to 8x minus 3 and mg is equal to 6x plus 1, find the value of x and fg. Okay, so we have a line segment fg, and they said m is the midpoint, so m is in the middle. So if m is in the middle, that means fm has to be congruent to mg by the midpoint theorem. Okay, so and so now we know that fm is congruent to mg, and so these are going to be equal to each other by definition of midpoint. Okay, so we're going to say 8x minus 3 has to equal to 6x plus 1. They have to be equal to each other. And we solve that, so subtract 6x on both sides. We got 2x minus 3 equals 1. I'm going to add 3 to both sides. We got 2x equals 4. Divide by 2. So we get x equals 2. All right, so we found the value of x, and now we have to find fg. And so fg, remember, is the total length of the line. So we're going to need to figure out what fm and mg are. Now, fm and mg are the same thing. Okay, so let's plug it into here. Fm is 8x minus 3, so 8 times 2 minus 3. So that's 16 minus 3 is 13. So these are both 13 right here because they have to be the same. And so by the SAP statement, we have fm plus mg equals fg. So to get fg, we just have to add 13 plus 13. Okay, so we got 26. All right, so that's number 2. So let's move on to number 3 here. All right, so number 3, it says a map of a hiking area is drawn so that the visitor center is at the origin of a rectangular grid. 2 hikers are located at positions -4, -4, and -1, 2 with respect to the visitor center, where all units are in miles. A campground is located exactly halfway between the hikers. What are the coordinates of the campground? Okay, so there has to be a campground somewhere here, well, we can somewhere in the middle between those two. So that means it's halfway. So we're talking about midpoint, okay? So the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. And that's in your formula sheet for geometry. All right, so we can call this x1, y1, x2, y2. We just have to add the 2 x coordinates, divide by 2, add the 2 y coordinates, divide by 2. So you have -4 plus -1 divided by 2. And then for the y coordinates, -4 plus 2 divided by 2. Okay, so we get -5 divided by 2, or just a fraction. And then we get negative 4 plus 2 is negative 2 divided by 2, which is negative 1. Okay, so we can leave it as a fraction here, but then write this as negative 1. All right, so that's number 3. So number 4 says find the coordinates of point W on ST such that the ratio of TW to WS is 1 to 4. So first off, you're going from T to S. So T is number 1 and S is number 2, okay? So that means, you know, T is x1. You got to be very careful with this, okay? So T is going to be x1, y1, or x1. So this is going to be x1, and then S is going to be x2. So you just got to be careful when you do that, okay? And then so then this is going to be M, and this is going to be N, all right? So we have, when we write the section formula, remember the section formula is x equals nx1 plus mx2 over m plus n. Okay, and so we have n is 4, x1 we said is 3, m is 1, x2 is negative 7, and then m plus n, 1 plus 4. And so we have 12 minus 7 is 5, 1 plus 4 is 5, so you get 1. Now we're going to see if this is correct, okay? So this is supposed to be point W, and so we can see that from TW to WS, it's a ratio of 1 to 4. Now, does that make sense? Well, yeah, because how many of these fit on the left side? Well, it's 1, 2, 3, and 4. You can see four of the units on the right side fit on the left side. So it's truly a 1 to 4 ratio from TW to WS. Okay, this is just to check your work, but the answer is x equals 1. Or the coordinate for T, the coordinate for W is W equal to, yeah, I'm just going to write the coordinates of W are x equals 1. All right, or you could say W equals 1, right? You can also say W equals 1, you know, either one. Okay, so if B is the midpoint of AC with C 5, 8, and B negative 6, 12, what are the coordinates of A? Okay, now B is the midpoint, okay? We told you what the midpoint formula is, but we're going to write the midpoint formula in a slightly different way. We're going to write it as x equals x1 plus x2 over 2. And then we're going to write the y as y1, or y is equal to y1 plus y2 over 2. And so x and y are the coordinates of my midpoint, okay? So we can, what I'm going to do is I'm going to call this xm and ym. This is going to be for the midpoint, okay? The x coordinate of the midpoint, the y coordinate of the midpoint. Now, they said that B is the midpoint. So that means that this is xm, and then this is ym, okay? So we're going to plug that in for the midpoint here. So we're going to say negative 6 equals, and then for the ym is 12 equals. All right, now C is not a midpoint, so we're going to call C x1, y1. And we don't know what x2, y2 is. That's what we're trying to find, okay? So, so we have x1 is 5, and then y1 is 8, according to that. So plus x2 over 2 plus y2 over 2. And we're trying to solve for x2 and y2. So we're going to solve these equations individually. So to get rid of this, remember, fraction bar means division. So we're dividing by 2. So to get rid of division, we got to do multiplication. So we're going to multiply both sides by 2. Whatever we do on one side, make sure to do on the other side. So we're going to do that here as well. So that those cancel. And so we have 2 times negative 6 is negative 12 equals 5 plus x2. And then we got 24 equals 8 plus y2. Now we're going to subtract 5 on both sides to get rid of that. Subtract 5 on both sides. Here we're going to subtract 8 on both sides to get rid of that. So we get negative 17 is equal to x2. And we get 16 is equal to y2. And so the coordinates have to be negative 17 and 16. And the answer is this one right here, the first one. All right. Number 6, in the figure, BA and BC are opposite rays. Okay, BH bisects angle EBC and BE bisects angle ABF. Okay, so bisects means cuts in half. So BH is cutting this angle EBC in half. Okay, that angle is getting cut in half. So that means, yes, it's BH bisects angle EBC. So that means this angle here is congruent to this angle here. Okay, those two angles are congruent. And then it says BE bisects angle ABF, and so that means this is congruent to this, which they already labeled it there. Okay, so now it says angle ABF is equal to HW minus 6. Okay, so they're saying that this little angle here is 8W minus 6, and then ABE, this little angle, is 2 times W plus 11. So actually, we don't really need this information, the bisects part, as just extra information. Really, we only have to focus on these two, but we know that these two have to be equal. So based off of this information here, okay? All right, so that means bisect means cut in half, so those two are the same, so we're going to set them equal to each other. 2 times W plus 11, and then we're going to find EBF. So EBF, or what is EBF? Oh, hold on a second. This is ABF, so I need to be very careful with this, how I label it, okay? So it's not EBF, it's ABF. So ABF is this whole angle here. So I'm going to say, okay, this whole angle is 8W minus 6, that entire angle that you see there, okay? And ABE is 2W, 2 times W plus 11, okay? So in fact, it's not going to be equal. We know that that if this is 2 times W plus 11, then this has to be 2 times W plus 11, right? Because it's the same on both sides. And so what we're going to say is, okay, well, both of these combined, the 2W plus 11 has to make the 8W minus 6, okay? That's what we're going to do. So the 8W minus 6 is basically two of these, okay? So it's 2 times W plus 11, and then another 2 times W plus 11. Okay? So basically there's a total of 4 of these, right? So I'm going to write this as 4W plus 11. There's 2 of them, okay? So that's one way of looking at it. Another way of looking at it is that half of this is equal to that, right? So we can cut the 8W minus 6 in half, and that would be equal to the 2W plus 11, okay? There's a couple ways to do it. It's not just one way. But I'm going to stick with this way. All right, so now we're going to distribute the 4. So we get 4W plus 44. We get 8W minus 6 is equal to that. Now we're going to subtract 4W on both sides, get the W's to one side. So that's 4W minus 6 equals 44. And we're going to add the 6 to both sides here. We get 4W equals 50. Divide by 4. So you get 50 over 4. So W is equal to 12.5. Okay, that's your decimal. So now we're going to plug it in to get EBF. Now EBF is this, okay? EBF is equal to 2 times W plus 11. All right? So we're going to plug it into there. 2 times W plus 11. You get 2 times 12.5 plus 11 is 23.5, and then multiply those together, you get 47. So 47 degrees looks like. Okay, so that's that. So number 7, refer to the figure, select 2 vertical angles. Okay, remember, two vertical angles are when you form an X and 2 lines cross, they form an X, and then you're looking at the angles that do not share a side. They're across from each other, opposite. Okay, so those are vertical angles, and then these are vertical angles as well. Okay, so here, notice that you form an X here, so you can look at the opposite angles for that. You also form an X here, so that's you can do those opposite angles as well. Okay. All right, so let's look at it. MQN and NQR. MQN and NQR. No, those are adjacent or linear pair. Those are not vertical. So we're going to cross this out. Can't be that. MQS, MQS, and NQS. Right? So no, those are not vertical because they share and all that. So no. SRQ, SRQ, and TRP. Yes, those are vertical because they're on opposite sides. They form an X and then they're on opposite sides. So we're looking at that angle. Okay, that's the answer. Okay, and then I'm going to label those like that. Those are vertical. Okay, that's it for that one. Just the definition of vertical. Now find the values of X and Y. Okay. So we know that they say that this is 2y, this is 114, this is 3x minus 24. So first off, we have an x here, right? We have an x, and so that means because we have the x that these are vertical, okay? Those are opposite sides, and vertical angles are congruent according to the vertical angles theorem. So we are going to set those equal and solve. Yeah, 5x equals 110. Divide by 5 on both sides. Yeah, x is equal to 22. All right. So that takes care of that. And so now what we're going to do is we know that the 3x plus, I'm going to get rid of this because there's too many things going on. So we have the 3x minus 24, we have the 2y, and we have the 114. Notice that they form 100, they form a straight line, right? They form a straight angle, which is the straight line. So that's 180 degrees, okay? So that means that those 3 angles, 1, 2, 3, add up to 180, okay? So they form kind of like a linear pair. I guess in this case it was more like a triple, right? A triple of angles that form 180, okay? So that's what we're gonna do. We're gonna add those together. We got 3x minus 24. Now we know what 3x minus 24 is, so what I'm going to do is I'm just going to plug 22 into that right now just to see what that is. So that's 66 minus 24 is 42 degrees. Okay, so this is 42 degrees. So we're going to do 42 degrees plus 2y plus 114. Okay, so 42 plus 2y plus 114 has to add up to 180. All right, so let's combine the 42 and the 114, and that turns into 156. And now I'm going to subtract 156 on both sides. And because I'm running out of room, I'll just do it over here. So we got 2y equals 24, then divide by 2. Get y equal to 12. There you go. All right, number 9. The coordinate grid shows an equilateral triangle that fits inside a square. Equilateral means all sides are the same, okay? All sides are congruent. Okay, so that means all of these are congruent according to that equilateral, and it fits inside a square. And a square, we know that all the sides of the square are congruent. Okay. Find the area of the square. Okay. All right, so the area of a square is the same as the area of a parallelogram, which is base times height. Okay. Now the area of a square is just the base times the height. The area of a triangle is 1/2 base times height. Make sure you know these formulas. Okay. Basic formulas, but you just have to know them. Okay, so in this case, the s is the side of the square. So another formula for this is s squared. I don't know why they have that here. You know, if they're just asking for the formula or the area, then just find the area. But here they're saying that s is the side of the square. So how long is it? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. 1, 2, 3, 4, 5, 6, 7, 8. It's a square, so it's 8 all the way around. So you just have to do base times height, 8 times 8. So s is equal to 8. That's the side, the length of the side. So it's just 8 times 8, base times height, right? So 8 times 8, which is 64. Okay, so it's 64 units, they want us to show work here. So it's 8 to the second power, right? If 8 times 8, basically. Which is 8 to the second power, which is 64 units squared. Find the area of the triangle. Okay, so okay, this is 1, 2, 3, 4. This is 4 units, so that's the base. So we have 1/2 times 4. Now the height has to be at a right angle to the base, so this has to be the height. Remember, it has to be at a right angle. Okay, so we got to count that. So how do we know that? Well, it's from 0 to square root of 3. So the height is actually square root of 3 for the height, okay? Because this is square root of 3, and then this is 0. So square root of 3 minus 0 is square root of 3, okay? So the height is square root of 3. So we get 1/2 times 4, which is 2, and then 2 times square root of 3. So you also have to be careful with the units because I messed up here. Yes, this is 8 spaces, but it's not 8 units. So you got to be very careful because look what they do. You're going from -2 to 2. So there's 8 spaces on the grid, but they're really trying to trick you here. Because they're going by 1/2, okay? Each of these units is 1/2, so be careful, guys. This is 1/2, 1, 1.5, and then 2, okay? So it's actually not 8 here, it's actually 4, okay? So let me correct that, because you see I almost made that mistake there. So this is 4, and this is 4. So be careful when you're looking at the graph to be careful with the spaces because they love tricking you like that. So be careful with how much each space is. Each space is not 1. Each space is going by 1/2 because you're going from -2 to 2. Be very careful again, guys. So we got this is 4, and so this is going to be 4 to the second power. All right, so it's 4 times 4. I'm just going to show my work here. 4 times 4, 4 to the second power, okay? So sorry about that, just wanted to fix that. Okay, so this is 16. All right, so now that means that right here, this is not 4, this actually should be 2, right? Okay, because it goes by 1/2. So it's from -1 to 1. All right, so the base is 2, not 4. The height is square root of 3, so the area is 1/2 times 2 times square root of 3, and half of 2 is 1, so it becomes 1 square root of 3, or just square root of 3. Okay, so 1/2 times 2, which is square root of 3 units squared. All right, be very careful again with that. Number 10. Find the area of the square that is not covered by the triangle. So still looking at the same thing, I guess. Select an exact value and then round to the nearest tenth. Justify your reasoning. Okay. The area covered by the triangle is blank. The area of the square, blank the area of the triangle. Okay. So to get the area that is, find the area of the square that is not covered by the triangle. That means it's all of this, everything except the middle part of the square where the triangle is. So you just have to take the area of the square minus the area of the triangle, and that's going to give you the rest of the square, okay? So we're going to need to subtract the two areas, okay? So the area not covered by the triangle is equal to the area of the square minus the area of the triangle. All right, so A is equal to, I'm going to use that blank, 16 minus square root of 3 units squared, or about, so now we're going to need to do this on the calculator, right? So we're going to do 16 on the minus square root of 3 on the calculator is 14.3. Okay, so about 14.3. All right, so it's that, so 14.3 units squared. Okay, that takes care of number 10. All right, number 11, fill in the blanks using the available answer choices. Identify the type of congruence transformations shown as a reflection, translation, or rotation. Okay, so here it's flipping, right? So it's a reflection, right, guys? So we got a reflection. So number 11 is that. Number 12, in the figure below, the measure of angle 2 is equal to 136 degrees. Find the measure of angle 1. Okay, so we have 136 degrees for that. We want to find angle 1. And so now these add up to 180 degrees because they form a linear pair. Okay, they're a linear pair. Okay. So so the theorem is called supplement theorem. So by the supplement theorem, they add up to 180, okay? So measure of angle 1 plus measure of angle 2 equals 180, all right? All right, so then if I want to find measure of angle 1, I just have to do 180 minus 136, which is 44 degrees. That's all there is to it, guys. Really simple. But I do want you to know the names of the terms, okay? All right, so number 13 says find the lateral area and surface area of the solid, round to the nearest tenth if necessary. So right now this is a prism. It's a triangular prism. We know that because the base here is the same. So notice that they have the same triangular base. Okay, so it's a triangular prism. So we know it's a prism, and we know that the base is a triangle. So I'm going to so hold on, before I draw the base, let's look at the formula to see what we need. Okay, so we're going to look at the formula sheet for the EOC, and we're going to go over here and then the second part, and it's going to give us formulas for the different solids and shapes. So we're looking at a prism, so the surface area is 2b plus ph. Okay, remember that they use a little h here, but I like to use the big H. Okay, and the b here is the area of the base, and it's a triangle. Now they do not give you the area of a triangle. They give you the area of a parallelogram or square or rectangle, but not a triangle. But we talked about that area in that previous question. Okay, so we write that formula there, 2b plus ph. So okay, so we have the surface area is 2b plus ph. Okay, now this part right here is the lateral area. Okay, and then this formula is the total surface area. Okay, so we're going to find both. So the lateral area is, which they call L here, right? It's the same thing, is pH. Okay, so let's do that. So and I use big H instead of little h. Okay, so the shape of the base is a triangle here, right? And it's 12 centimeters here, and the height has to be at a right angle to it. It's 10.4 centimeters. And it's 12 centimeters here and 12 centimeters here. Now we only need to find the perimeter of this triangle, so we do not need the 10.4 for the lateral area. Okay, so let's go ahead and find the perimeter. The perimeter is when you add up the three sides of the sides of the triangle, the sides of the shape. So we have 12 plus 12 plus 12. That's 36 centimeters. Okay, so we can plug that in for the perimeter. Now the capital height is the height of the prism itself, okay? Which the height of the prism is what gives it 3D, Okay, so the height of the prism is this, capital H. So I'm going to use capital H there, blue, and then I'm going to do this red. Okay, so we have 36 times capital H is 8. So we have 36 plus 8. Let's do that real quick. 36 times 8 is 288. Okay. So we have that this is 288 centimeters squared. All right. Okay, so now what we're going to do is we're going to find, I'm going to call this capital B. So now, because we're going to find the area of this triangle. So capital B is the area of the triangle. Now the area of the triangle is 1/2 base times height, little b, little h. The base and the height have to be at a right angle to each other. So it's got to be these two sides, which are at a right angle. You see that right there, at a right angle. So so it's going to be 1/2 times 12 times 10.4. Okay, so 1/2 times 12 times 10.4 is 62.4. Okay, so we got 62.4 centimeters squared. So we're going to plug that in for the surface area. So 2 times 62.4 plus what we have found here, right, which is the 36 times 8, right? And that gives us a total surface area. Okay, so 2 times 62.4 plus 288 is going to give us our total surface area, which is 412.8. Okay. All right, so there you go, 412.8. All right, so that's number 13. All right, let's move on to number 14. So it says a basketball can be modeled accurately by a sphere. The basketball has a radius of 4.7 inches. We got radius of 4.7 inches. What is the approximate surface area of a basketball? Round your answer to the nearest tenth. So we're going to go here to a sphere. The surface area is 4 pi r squared. So really straightforward. So we have surface area equals 4 pi r squared. We have 4 pi times 4.7 squared. We're going to use the pi button. We're going to actually use the value of pi, not use 3.14. And so 277.59, which is to the nearest tenth, we're going to be bumping this up to a 6. Okay, so 277.6 inches squared. All right, number 15, identify the shape of the cross section. So notice that when you cut this, you get this shape right here, which looks like a pentagon. So pretty straightforward. All right, so let's look at number 16. Identify the solid formed by rotating the two-dimensional shape about the line. And then we have some answer choices to pick from. Okay. Notice that there's a gap here. So this gap is going to be, you're going to basically rotate this part, and it's going to be a hole, right? It's just going to be like a hole. Now this part right here rotates around like this to kind of make like a, almost like a, and this part rotates like that, right? And so it kind of looks like that when it reflects and rotates. So it kind of it's called like a truncated cone. Basically, what it looks like, a truncated cone. So it's kind of like a cone with a cylinder in the middle, a hole in the middle. Okay. So it's not quite a cone. It's not quite a cylinder. Is a cone with a cylinder removed from the middle, basically. Okay. So so it's going to be this answer. All right, number 17. Fill in the blanks using the available answer choices. So it says identify the hypothesis and conclusion for the conditional statement. Then write the statement in if-then form. Okay, so we want to identify hypothesis and conclusion for the statement. So it says get a free bottle with a 1-year membership. Okay, so basically you have to buy a 1-year membership in order to get a free water bottle. Okay, so basically if you have a 1-year membership, then you get a free water bottle. Okay, So that's your if-then statement. Okay, so if you buy a 1-year membership, then you get a free water bottle. So anything following the if is the hypothesis, okay? So so this is going to be the hypothesis, this is going to be the conclusion, right? So the hypothesis is you buy a 1-year membership. And conclusion, you get a free water bottle. Okay, really as simple as that. Okay. Number 18, it says, to negate a statement containing the words all or for every, you can use the phrase at least one or there exists. To negate a statement containing the phrase there exists, use the phrase for all or for every. Okay. So they give you a bunch of statements. So they say P, all polygons are convex. And then they give you an example. If you want to negate that, you would say at least one polygon is not convex, basically. Okay. Okay, and then the next one says, sometimes there are phrases that are maybe implied. For example, the square of a real number is a non-negative, implies the following conditional and its negation. Okay, so the square of a real number is non-negative means that for every real number x, then if I square it, that gives me a non-negative number, so greater than or equal to 0. Okay, so it says, use the information above to write the negation of the statement. There exists a student who has at least one class in the C wing. Okay, so if we wanted to do that, we would probably want to use this information right here. There exists a real number x such that x squared is less than 0. So there exists a student. So there exists a student with at least one class. So I'm going to say there exists a student with x is greater than or equal to 1. That means they have one class or more. Then if you want to negate that, you would have to use for every student. So for every student, x has to be the opposite. So the opposite of greater than or equal to 1 is that it's less than 1. Or in other words, x is equal to 0, right? So for every student, there are no classes. So in other words, no student has, or you could say no students have any classes in C-Wing, okay? So all students have 0 classes. In other words, no students have any classes. So the best answer is no students have any classes. Not a student has no classes, it's all students have no classes. So that means no students have classes. So it's got to be this one. Okay? That one's a really interesting question. I'm not sure why they would ask a question like that, but at least you have an idea for that. So number 19, describe the translation from the preimage f to f prime. So you're talking about a translation, so that means you're moving it from one to another. So notice that here, if you add 5 to -3, you get 2, right? Because -3 plus 5 is equal to 2. And if you if you subtract 1 from 1, you get 0. So we have that the translation vector is 5, -1. Or in other words, that the translation rule is x plus 5, y minus 1. So you add 5 and then take away 1. All right. So that's good. All right, so now let's look at number 20. All right, so number 20 says triangle ABC has the following vertices. Triangle ABC is translated 7 units to the right. So it says here, okay, so 7 units. 1 second here. All right. Let's just zoom in here a little bit. Okay, so we got it's translated 7 units to the right. Okay, so here 7 to the right and 5 down. The result is triangle A prime, B prime, C prime. It says write the general rule that describes the translation. To write the rule, first write a form with appropriate signs. Okay. All right. Then fill in the blanks with whole numbers to describe the translation. Okay, so it says 7 to the right, so that's plus 7. And 5 units down, that's minus 5, guys. So we're going to be choosing this option right here. And we're going to go x plus 7 and then y minus 5, okay? Because you're 7 to the right and 5 down. And then we want to write the coordinates a prime, b prime. So basically you're going to add 7, take away 5, add 7, take away 5, add 7, take away 5. And so that means a prime, negative 7 plus 7 is 0. 5 minus 5 is 0. We got negative 8 plus 7 is negative 1. We got 8 minus 5 here is 3. We have negative 4 plus 7 is 3. And then 4 minus 5 is negative 1. That's what we have. All right, so looks like on 21. So it says an architect places 3 new buildings as shown. She decides to move building B by rotating its center 90 degrees clockwise about the center of building A. Give the coordinates of the new center of building B. Okay, so first off, with this picture, it's really hard to tell. The lines are not very well drawn here. In the original, it's well drawn, but here, for some reason, it doesn't draw very well. So this is 13 over here, and then A is at a coordinate of 6. Okay, so this is 13, 6, just so you're aware. And B is at 17 here, and at a y coordinate of 1, 2 right here. So it's 17, 2. Okay. And let me just draw this a little bit better. It's hard to tell. 10, 9, 8, 7, 6, 5. Okay. We got 1, 2, 3, 4, and 5. Okay. That's a little bit better. Just hard to tell. So what we want to do is we want to rotate this 90 degrees clockwise, so it's that way, okay? So it forms like a right angle like that, okay? That's what we want to do. So we want to figure out where it ends up, okay? So don't draw this line just yet. I'm just showing you a visual. So we need to figure out, okay, where does this end up so it's at a right angle? So there's 2 ways that you can do this. You can understand the concept of perpendicular slopes, like 2 lines that are perpendicular. We know that 2 lines that are perpendicular have slopes that are reciprocals of each other, negative reciprocals, meaning that the slopes flip and they change sign. They change from positive to negative or negative to positive. So what we can do, one way is to find the slope of the original line AB, right, from A to B. So if we can find that slope. So let's do that. So it goes from 13 to 17, so it's going over 4. And it's going from 6 to 2, so it's going down 4. So the slope of that is rise over run, so negative 4 over 4. Okay? Now, what we need is the slope of the blue. Okay? So we need the slope of the blue part. But we know that for it to be perpendicular, it has to be flipped and change signs, okay? So when it flips, obviously it's going to be the same, 4 over 4, but it's going to go from negative to positive, okay? So now it's going to have a positive slope. And so now we know that this has to go 4 to the left from A. It has to go 4 to the left and 4 down. So where does that put it? Well, we would have to take the coordinate for A, right? The coordinate for A is 13, 6. And we'd have to go 4 to the left and 4 down. So that puts it at a coordinate of 9, 2, which is basically right here. That's the coordinate, 9, 2. Okay, so that is where the new coordinate is going to be. So that's method 1, okay? So method 1 is using slopes, okay? Now, method 2 is the normal way to do it. when I say the normal way to do it, I mean like using transformations, okay? So the transformation method, which is generally what they want you to do, is which is basically you take the A and you move it at the origin. So you move it so that it goes at the origin. Okay, so right now A is at 13, 6, right? So you're going to move it so it goes at the origin. That means you're going to go 6 to the left, 13 to the left, and 6 down. And that will make it go to the origin. But if you do that for A, you need to do that for B as well. Okay? So B is 17, 2. You're going to move 13 to the left and 6 down. And that's going to convert B to 4, negative 2. All right, next you're going to want to apply the 90-degree clockwise rotation rule. Okay, the 90 degrees clockwise rotation rule is xy maps onto y negative x. Okay, so you just have to know that rotation rule, again, because it's a transformation rule that you have to memorize. They don't give you the formula for that. Okay. And then we can apply that transformation rule to each of these. But really, we only care about doing it for B, not really for A, because we only care about B. Okay, so we're going to do the 90-degree clockwise rule for B. So that means we have to switch the coordinates, right, and then put a negative on the second one. So we switch these. So it's negative 2, 4, and then put a negative on the second one, so it becomes negative 4. All right, now it's been rotated. Now what you do is you move it back. So since we moved it 13 to the left and 6 down, we're going to go ahead and reverse the process, go 13 to the right and 6 up. And that'll move it back where it needs to be. So that's going to be, and I always do this. I did this last time too. I'm not sure. I just did the math here. So it's 17, it's 2 minus 6 is negative 4. I don't know why I keep saying it's negative 2. 2 minus 6 is negative 4. Okay, so this is negative 4 right here. So negative 4 plus 13, that's 9. And then negative 4 plus 6 is 2. So you get 9, 2, which is exactly what we got there. Okay, so those are two methods to do the same, to get the same result. All right, so now let's look at number 22. Number 22 is way easier than 21. Find the measure of the missing angle. Now this is a triangle, so the angles in a triangle add up to 180. This is called the triangle angle sum theorem. Okay, know the names for the theorems. They add up to 180, the interior angles. So we get x plus 38 plus 53 equals 180. I'll just call that x there. And so we add these together. X plus 91 equals 180. So subtract from 180. And you get 89 degrees. Really straightforward. 23, the triangles below are congruent and the corresponding parts are marked. Name all the corresponding congruents and angles and sides. All right, so angle A has the double marks there, and so does Z. So A matches with Z, so angle Z. Angle B has the 1 mark, and so does Y, so angle B is congruent to angle Y. Angle C has the 3 marks, and so does X, so it's congruent to angle X. All right, so now AB, side AB, which is this one has the 3 marks. Well, this one has the 3 marks, so it has to go to side ZY or YZ, same thing. AC, it has the 1 mark, and so does this one, so it matches up with ZX or XZ, same thing. And BC has the double marks, and so does this one, so it'll match up with YX or XY, again, same thing. And now to do the congruent statement, triangle CAB, we know that C matches with X, right? So C has to match with X. We know that we know that A matches up with Z, right? So Z. And we know that B matches with Y, so it has to be Y. Okay, and that's really all there is to it. You just got to match them up, okay? All right, so number 24, guys. Use the given information to prove that triangle PQR is congruent to triangle TSR. Okay, so we want to prove triangle PQR is congruent to triangle TSR. Okay, so first off, we're given that QR is congruent to SR, right? So QR is congruent to SR. So we're going to mark that in our diagrams. And then we have, so we're going to put that as a given, okay? So we're going to do a statement and reasons, or reason. And so for number one, we're going to say with the given, right? So QR is congruent to SR, and that's because it's given. And we'll do the same thing for number two. PR is congruent to TR, and that's given. All right, so PR is congruent to TR. Okay, so notice that we want to prove them congruent. And so if we want to prove them congruent, we're basically left with a few theorems. We can prove them congruent by S is S, SAS, AAS, or ASA. Or HL, but HL is only for right triangles, okay? Now, we don't know that these are right triangles. They don't say anything about that. So because they don't say anything about right angles or perpendicular, we're probably not going to use HL. So we're probably going to use these. Now, notice that if we're going to use the side, angle side, the stuff like that, then notice that we have two sides. We have the S there, and we have the other S there. So if we can prove the other side, or if we can prove another angle, then we're good to go. Now notice that we do actually have an angle, because notice that these angles right here are vertical, and because they form an X, okay? Anytime you see that X there. And so that means, that essentially means that, that these angles right here are vertical, okay? So we're gonna go ahead and say that. We're gonna say angle PRQ is congruent. This is PRQ right there. And we're going to say that that's congruent to TRS. All right, so that's what we're going to say. Angle TRS, and that's because of vertical angles. Vertical angles theorem, or property, or whatever you want to call it. Okay, vertical angles theorem. All right, and so that gives us an angle, guys. So now we have angle. So now we have side, angle, side. You see that? Side, angle, side. And side, angle, side. And that's one of our theorems, okay? So we're going to be using this one right here. So therefore, we could say that these triangles are congruent. So we're going to rewrite the proof statement by side, angle, side. Congruence. Okay, so that's the end of the proof. Okay, so it's just a 4-step proof. All right, number 25. For each part below, use the figure to fill in the blank. Okay, so it says find the measure of angle K. All right, so notice that this is an isosceles triangle, because the two sides are the same. And so by the isosceles triangle theorem, this states that if the two sides are the same, that means that the two opposite angles must be the same. That means this and and angle L has to be the same. That means this has to be 40 degrees as well. Okay? So by the isosceles triangle, this means that the measure of angle J, we could just say, well, what I'm going to say is angle J is congruent to angle L. Okay, so those are both 40. And by the triangle angle sum theorem, the angles in a triangle added to 180. So I'm going to call this X, and then I'm going to solve for X. We got X plus 40 equals 180. So this is 80. Subtract 80 from 100, or from 180, and you get 100 degrees. So that's equal to angle K. All right, so now part B, it says find HI. Now HI, notice that all of the angles are the same, which means that if all of the angles are the same, it's equilateral. It's an equilateral triangle. Okay, this is an equiangular triangle. Equiangular means all the angles are the same, but it's also equilateral, because if the angles are the same, that means the sides are the same. Okay, so that means if this is 4, this is 4, and then this is also 4. Okay, so it's an equilateral / equiangular triangle. Equiangular means same angles, equilateral means same sides. So that's it. So HI must be 4. And that's it. By the way, that also means that these angles have to be all 60 degrees if they ask for that. Because if they're all the same, 60 plus 60 plus 60 is 180. All right, so number 26. Wrap this up shortly. All right, so this is number 26. The table below gives the material of each item in Donna's jewelry box. These are the only items in her jewelry box. Okay, so we have a bunch of items and then their materials. Okay, a conditional statement is given below. Give the converse, inverse, and contrapositive of the statement and use the table above to decide if each statement is true or false. Assume that any item mentioned comes from Donna's jewelry box. Okay, so the given statement, if an item is a pendant, then the item is made from copper. So we have to determine whether that's true or false. Okay, so if pendant, right? So if pendant, then copper, right? That's true. Okay, so this is a true statement. All right, so that's good. Now it says now we're gonna do the converse. Now the converse, remember that this is P and then this is Q. Okay, so it's P implies Q. So that's the original. Okay, now the converse is when you switch the two statements. So Q implies P. So when you switch or reverse the statements. The inverse is when you negate the original statement. So you negate both the P and the Q. And then the contrapositive is when you negate the original statement and you switch it. Okay. So like that. Okay. So now let's do the converse. So the converse, I have to switch the two statements. So if an item is made from copper, if I switch that, Q is going to go first. Then the item is a pendant. Okay. Okay, so that's what it looks like when you switch them. And we want to see if that's true or false. Okay, so if an item is made from copper, then it's a pendant. Okay, so we got copper, then that leads to pendant. So that's true there. However, what if it was copper and it led to a necklace? Well, then this will be false, right? So therefore, this overall has to be false because it doesn't have to lead to a pendant. It could be a necklace, okay? So that takes care of that. So now the next thing we want to do is the inverse. Okay, so we want to negate the original statement. So negate the item is a pendant means that the item is not a pendant. And then negating Q, the item is made from copper, is going to be it's not made from copper. Okay, so if an item is not a pendant, then it's not made from copper. Okay, so that's what we're going to do here. If an item is not a pendant, then the item is not made from copper. And we want to see if that's true or false, okay? So if an item is not a pendant, then it's not made from copper. So we want to see if that's true or false, okay? So it's not a pendant, so that means it could be a ring, bracelet, necklace, or hairpin. And then it says it's not made from copper, okay? So if it's not a pendant, it's not made from copper. So what we want to see is if it's false, that means if it's not a pendant, it would still be made from copper. So like, okay, so we got some, if it's not a pendant, so like a necklace, well, a necklace is made from copper. And the statement said that if it's not a pendant, then it's not made from copper, right? However, we found the statement that was not a pendant, yet was made from copper. And so that proves that the statement is false, okay? All right, so we have that. All right, so now the contrapositive. We basically take the inverse and we switch it. So it's going to be not Q, not P. So if not made from copper, then not a pendant, okay? So something like that. Okay, so if an item is not made from copper, then the item is not a pendant. Okay, we want to see that's true or false. So if it's not made from copper, then it's not a pendant. Okay, so not made from copper. So that means platinum, silver, gold, right? So if it's not made from platinum, so platinum leads to ring, silver leads to bracelet. So far none of these lead to pendant. So gold here leads to hairpin. So yeah, if it's not made out of copper, then it's not a pendant. So that's true, according to what it says there, according to the diagram. Because again, here, this is not copper. It leads to not a pendant. This is not copper. It leads to not a pendant. This is not copper. It leads to not a pendant. So yeah, so I would say that's true. All right, so that takes care of that. So let's look at number 27. Okay, so number 27, it says in the figure below, K is parallel to G. Find the values of Z and X. Okay, so we say K is parallel to G. So this is the symbol for parallel, the little arrow. Now, if they're parallel, then we want to use a sandwich model. Okay, so the sandwich model: bread, bread, and toothpick, or parallel lines, and then the transversal. Okay, so it turns out that these two angles here are consecutive interior angles. They're inside the sandwich. And they're on the same side of the toothpick. Now, consecutive interior angles add up to 180. Okay, so add to 180. So that means that Z, so 83 plus Z equals 180. So Z equals 180 minus 83, which is 97 degrees. Okay. All right, so, or Z is just 97. All right, okay. So we got Z. Now we have to find this. Now we know that this forms an X, and so these are actually vertical angles. Okay, so whatever Z is, that's what that other angle is equal to. Okay, so I'm going to say this is congruent to that. So Z is equal to 4x minus 39. So 4x minus 39 is the same as Z, but Z is 97. Okay, so we set that equal to 97 and solve. So we add 39 to both sides. We get 136, then divide by 4. We got x equals to 34. All right, there you go. That's 27. Number 28, use the figure and the given information to determine which lines of any are parallel. Choose the correct justification if necessary. All right, so they're saying angle 6 is congruent to angle 12. So they're saying this is congruent to angle 12. So what kind of angles are they? Well, those are alternate interior angles. So if I just ignore this and I just focus on this bread, and then this toothpick, then those are alternate interior angles, okay? So we would expect that A is parallel to B, okay? So we would say, yeah, A is parallel to B. We would choose this, and that would be by the converse of the alternate interior angles theorem, okay? The converse is when you try to prove that the lines are parallel, okay? Okay, so there's that. I guess you have an answer choice here. So that's what the theorem is called, but I guess you would choose this choice. If the alternate interior angles are congruent, then the lines are parallel. So I guess you should put that in the blank too, in that blank right there. Okay. All right, so let's look at number 29. So find the area of the parallelogram EFGH. Be sure to include the correct unit in your answer. Okay, so find the area of the parallelogram. Now in the formula sheet, they give you the area of a parallelogram, which is base times height. So the base, here's the base, it's 19. And the height has to be a right angle to the base, okay? So, so in this case, this is at a right angle to the base, right? So then this has to be my h. right here, which is the same as this h. Now the thing is, so I'm just gonna call that h and not have this h here. So we're gonna call this h. The thing is though that we don't know what the h is yet. So what we have to do is use Pythagorean theorem in order to find it, because notice that this here is a right triangle. And so we can use Pythagorean theorem, right? Which is a squared plus b squared equals c squared. So we're going to use Pythagorean theorem in order to get h. Okay, so h squared plus 7 squared equals 25 squared. All right, those are the two sides, 25, 7, and h. Okay, those are the three sides. All right, so we get h squared plus 49 equals 625. So we're going to subtract 49 on both sides. So h squared equals 625 minus 49, which is it's 576. And then we have to get rid of the squared, we have to do the square root, okay? All right, so h equals the square root of 576, which is actually equal to 24. I'm going to double check that. Square root of 576, that's 24, okay? All right, so yeah, so it's equal to 24. So now we know that the h is equal to 24 millimeters. All right, so now we can plug it in. Area equals 19 times 24, and that gives us 456 millimeters squared. All right, that takes care of that one. So now we got number 30. Each region below is being rotated about the line L. For each region, identify the solid generated by the rotation. Okay, so if I'm rotating this by around this line, then that's going to give me a cylinder, right? So the answer's got to be this one right here. Okay, pretty straightforward. So now if I'm rotating about this line L like this, then that's going to give me a cone, right? So it's going to be this one right here. And if I rotate this around this line, then it's going to give me a sphere. Okay. Really, really straightforward. All right, guys, that's going to do it for this video. I hope you found this useful and informative. And as usual, I'll see you in the next one.